push that rock with Simpson math, graphing parabolas. So here we have a parabola already in its vertex form, and we want to graph it. But I'm going to pretend I don't know that the vertex is 2, 1. I'm going to pretend I don't know that. I'm just going to use translations to graph the parabola. So here's the parent parabola that we normally graph, y equals x squared, and we learn in middle school. But we want to graph this guy here. Well, we can tell that it's been dilated vertically, it's been shifted horizontally, translated horizontally, and it's been translated vertically up and down. So we'll just use those translations. Now, we might think minus means go to the left, but actually remember when it's horizontal translation or horizontal dilation, it's kind of opposite of what you think. So instead of going to the left, we're going to go to the right 2 units. So we're going to pick this point up and go over 2 units. I want my final graph to be in red, so I'll do this first in blue. So I'm going to shift this over 2 units, shift this over 2 units. I'm going horizontally because I'm looking at this shift here. Shift that over 2 units, so this landed on that. Shift this over 2 units, well, that'll land here, and then shift this over 2 units and it lands here. And here is the resulting shift to the right. So this is y equals x minus 2 squared. That's the blue curve there. Okay, but we also have this dilation happening. Okay, so the dilation is going to pull these points either to or away from the x-axis. Well, when it's larger than 1, it's going to pull it away from the x-axis, and it's going to double. It's going to do that action by doubling the output. So this output of 4, 1, 2, 3, 4, is going to become 8. So 5, 6, 7, 8. And this output of 4 will also become 8. This output that's 1 will become 2, and this output that's 1 will become 2, and if you double 0, you're still 0. And so this purple graph shows me the dilation of this graph. So it's y equals 2 times x minus 2 quantity squared. Okay? Now, I did that next because clearly everything's going to be affected by multiplying by 2 before it's going to be affected by this plus 1, just following PEMDAS. I did inside the parentheses, and then I did outside the parentheses, it would shift up 1. If I had a horizontal dilation, boy, I think I would just scratch this way of graphing and put it in the proper form and graph more brute force, because horizontal dilations can mess it up. But we don't have a horizontal dilation, luckily us. So the last thing to do is just pull this graph up 1. So this just shifts everything up 1. So this point goes up 1, 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 and this vertex goes up 1. And here is my resulting graph right here. And maybe that's not the best graph in the world, but there is the graph of y equals 2 times x minus 2 quantity squared plus 1 in red. Math made simple. Simpson math.